Number 15, identify the transformation. We have 4 different kinds of transformations at this point. I'm going to list them out right here. We have number 1 is a translation. That's where something moves up or down or left or right. We have a rotation, where a shape is rotated around. We have a reflection, where a shape might look like this, and then we'd have a mirror image of that shape, where it's reflected here. And we also have a dilation, where a shape might get smaller or larger. So we have circle A, B, C, D, and we have a new circle A prime, B prime, C prime, and D prime. Notice that the diameter from A to C, we're going to count that. We can see that our shape's getting smaller, and we want to see if it stays congruent, if it's a perfect dilation. So let's see. The diameter of A to C is going to be, let's see, 1, 2, 3, 4, 5, 6, 7, 8 is 8 units. Now let's check the diameter. Diameter was 8 units. Let's try the diameter of the smaller circle. Is 1, 2, 3, 4. Okay, so the diameter of the A prime to C prime is 4 units. So this is a dilation. And to use coordinates to describe, I'm not going to make you use coordinates on this, but I do want you to say our scale factor. So it's a dilation with a scale factor. What do we multiply 8 by to make 4? 8x equals 4. I want you to solve this. 8 times what equals 4? All right. It's not 2, because that would equal 16. So you're going to have to divide both sides by 8 and figure out what our scale factor is on this one. Number 16, are figures A and B congruent, similar, or neither? If they're congruent, we need to describe the transformation sequence. So let's see. We have A and B. This one goes, it has like a rectangle here that's 3 by 2, 3 by 2. Let's see if this one's the same. 1, 2, 3 by 2. Yes, 3 by 2, 3 by 2. This graph's a little bit stretched out, but we can see that these are congruent. Congruent means same size, same shape. Now, what's the transformation process that happens here? Well, I can see from this point here, I'm rotating my shape around this way, okay? So I notice I'm going over to the left, 1, 2, 3 on this axis. I'm going to do the same thing, but in the y-axis, 1, 2, 3. So that takes me to here. And then I go down by 2, so that new point is right here. That is now the front point of my shape. And my shape is now right here. Okay, so it's now here. So this is my new B. And I accidentally just realized I went from A to B, or B to A instead of A to B, but it's fine. So in the end, we'll just rotate it the other direction. So now we went from here on the right to this spot. So what is the first thing we're going to have to do is we're going to have to slide shape A to the left. So my first step is a translation. Left, how many units? Let's choose this corner. We're going to have to go all the way to the top left corner. We're going to go over 1, 2, 3, 4, 5, 6, 7 units. And then we're going to rotate as our second one. It's a rotation, 90 degrees, this direction, which is counterclockwise. It is possible to say we went clockwise this way. That would be 270 degrees clockwise. That works as well. Number 17, find the missing angle. I see I have two angles here. This angle is 120, and that will help us figure out what this angle is right here, which will be congruent to angle A because these two lines are parallel to each other. So I know that if this is my vertex here, I'm going all the way here. This is a total of 180 degrees. So if I cut that off at 120 degrees from here to here, what's remaining? So 120 plus what equals 180? Well, you see that this will be 60 degrees. So this one here is 60 degrees. And then the angle A corresponds to this one. That means they're the same. And we can see that they're the same. They're the same angle because these lines are parallel to each other. So they have the same angle values. Angle A equals 60 degrees. Now for angle B, we know that this is 130, so you need to find out what this measurement is from here to here. And that's going to be the same as B. So do the same thing that we did, but instead of 120 plus x, it'll be 130. And that's going to be it for that one. You can figure out what B is. Number 19, compare the sizes of viruses and bacteria. Explain. So we have two numbers here in scientific notation. We have 6.0 times 10 to the negative 8th, which means, well, 10 to the negative 8th, that's 10 to the negative 1 would be here, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. It's a really small number. I think I put too many zeros there. But this negative 8 means I need to move my decimal to the left 8 times. So 6.0 will turn into 1, 2, 3, 4, 5, 6, 7, 8. 0.000000060. On this one, it's going to be 6.1. Move our decimal over 7 times. 1, 2, 3, 4, 5, 6, 7. So it'll be 0.0000006 zeros here. Decimal point here. Which one of these is a larger number? And if we line up our decimal, we should see that that's not going to work. If we line up our decimal, everything on the top here is going to shift. I can't do it. To the right. So we end up having point. In fact, you take these two numbers, line up the decimal, count the zeros, tell me which one is a bigger number. You might have to add a 0 to the end of one of these to compare them.